We now know that not all of the atoms of a particular element are exactly the same as Dalton had speculated. We now know that for a particular element such as sodium, there must always be 11 protons. So the number of protons are always the same for a given element, but it is possible to have the mass be different for different atoms. And that is a result of having different numbers of neutrons. So, in this particular representation here, we have the nucleide symbol, which is the atomic symbol, which also then includes the mass number of that particular isotope, isotope being atoms of an element with different numbers of neutrons. And so in this case, the nucleide symbol for this particular isotope has a mass of 23. And of course, since it's sodium, the atomic number is 11. So isotopes are different forms of the same element. So it's possible for there to be more than one type of atom for any particular element based upon the relative number of neutrons. In the example shown here, we have one of the so-called isotopes of sodium. To be sodium, there has to be 11 protons, but also in this case, there are 12 neutrons. And so the overall mass of this particular nuclide is 23 AMUs. There are also 11 electrons orbiting or surrounding this nucleus. They are moving very rapidly, creating electron clouds. In addition to this particular isotope, there is a second isotope for sodium. In this case, there are again 11 protons, but only 11 neutrons in the nucleus. So its overall atomic mass is 22. Again, there are a total of 11 electrons surrounding the nucleus, and that would give you exactly the same net charge for both of these isotopes. So, by definition, isotopes are the same element, but have nuclides that are different in terms of the number of neutrons. Turns out that atoms are able to gain and lose electrons to form what we call ions. Ions are charged atoms or maybe groups of atoms. And it turns out that an example of this would be a sodium atom in which you have 11 protons which are positively charged and 11 electrons which are negatively charged, resulting in no net charge. Adding some energy produces a removal of one electron, and this gives you an atom with 11 protons in the nucleus, but only 10 electrons surrounding it, with a net charge of positive 1. This is the so-called sodium ion. Any positively charged atom or groups of atoms are referred to as cations. In contrast, if I have an ion that gains electrons, then this is going to form a negatively charged atom. In this case, I have a chlorine atom with 17 protons in the nucleus and 17 electrons surrounding the nucleus, or a net 0 charge. If I, again, give this an electron, we can then result in 17 protons in the nucleus, but now 18 electrons, which provides an overall negative 1 charge. A negatively charged atom or group of atoms is referred to as an anion.